At Epic, we have a foundry and some metal casting processes available. Casting involves pouring molten metal into a mold, which has a cavity in the shape of the desired part, and leaving it to solidify. This demo is primarily focused on casting aluminum in a sand mold. Investment casting and gravity casting into an expendable 3D printed or reusable silicone mold are also casting techniques available for small volume parts. Sand mold casting is an expendable mold reusable pattern process. The pattern may be made of any material and produced by any means. The only requirement is that it is rigid enough that it does not flex while the mold is packed. The patterns in this demo were milled out of a plastic sheet and fixed to an aluminum plate. The pattern is placed in the center of a two-part flask. The flask is made up of a cope, the upper part, and a drag, the lower part. The two halves of the flask are aligned with pins, so that when we remove the pattern, the cope and drag align properly. The removal of the pattern exposes the mold cavity and metal transfer system. When packing the flask with sand, patterns for channels to direct the flow of metal are included. The metal transfer system includes a sprue, a tapered hole through which the metal is poured, a runner system, or channels between the sprue and the parts, gates, where the runner meets a part, and one or more risers, which act as vents and reservoirs of molten metal as the casting cools. A mold parting powder, like talc, is dusted onto the part to ease removal of the sand from the pattern. A ram is used to pack the sand tightly into the flask. When the flask is completely filled, the patterns are removed and any loose sand is blown away. The mold is then closed by aligning the cope and drag, and finally it is transferred to the pouring station for casting. The process here is fully manual, but this can be automated in industry. The sand used for sand casting is a mix of fine clays and silica sands, which are mixed with either oil or water as a bonding agent. The casting sand used at Epic is called Petrobond, and it uses resin and oil to bond the sand. The sand will pack very tightly and will not shift when the flask is handled. When metal is cast into the sand, the oil in the sand near the part will burn off, so a large ventilation system is required for the smoke and any metal fumes. The Petrobond packs very tightly into the flask and is able to pick up detail from the pattern. After metal is poured into the mold, the sand is very hard and dry, so it is broken out into a muller, renewed with oil, and stored in a covered bin for reuse. Sand mold casting is the most common type of casting because it is a low-cost process and works for a large range of materials and part volumes. Casting processes, which use permanent dies, do produce higher quality parts at a more rapid pace. However, the cost of machining the die is prohibitive for small runs, and the die casting process does not work for very large parts. When designing a part for casting, you have to decide where you will split your part, or where the parting line will be. If there are undercuts where sand would be trapped and break out if you attempted to remove your pattern from the packed flask, then you will have to design cores to fill these areas of the mold. The pattern will make one cavity in the sand mold, so your casting will be solid unless you insert cores where hollow cavities should be. Cores are made of a different type of sand, formed in a custom mold, and fired before placing into the sand mold. Cores are also expendable and are broken away from inside the part after casting. All types of two-part mold casting methods can use cores, but shell casting methods, like investment casting, cannot. Patterns are also enlarged to account for shrinkage of the metal during cooling. Right angles can cause sand to break away when opening the mold to remove the pattern, so a taper or draft is recommended. All metals can be cast, but we restrict our lab to aluminum and other low melting temperature alloys for safety reasons. Casting is a quick way to form a part if you already have a pattern or permanent mold available. Casting is used for both prototypes and large volume production. The material properties of a cast part are not equivalent to a wrought metal part, and cast parts may require heat treatment to improve mechanical properties. Castings will have a lower density than wrought metals, and porosity can be an issue. When molten aluminum comes into contact with water vapor, hydrogen is formed. The hydrogen dissolves into the melt, but then as the part solidifies, the hydrogen comes out of solution and leaves bubbles in the solidified part. These bubbles are disastrous for the mechanical strength of the part. Fluxes containing chlorine and fluorine salts are commonly used to degas the molten aluminum. Sand casting is a gravity-fed process, and the sand itself is porous and allows gas to escape. Other casting processes, which use pressure, will have lower porosity than gravity-cast parts. The aluminum we use is recycled from the machine shop. This means our metal is a mixture of wrought alloys, which is not ideal for casting and may sometimes lead to failures like incomplete pores or excessive shrinkage. Casting alloy designations contain additives, like silicon, which reduce the melting temperature, increase the fluidity of the melt, and reduce shrinkage while cooling. The aluminum is placed into a crucible, which is made of refractory materials like clay-bonded graphite or silicon carbide. The amount of aluminum to add is determined by weight, and this is called the charge. Our furnace uses electrical resistance to heat the chamber. The furnace is designed to use a number 10 crucible like the one we are using here, so this limits the volume of the part you can cast. Large casting facilities may use furnaces which tilt and pour the molten metal for you, but our small lab furnace requires manual pouring. The crucible is lifted from the furnace and placed onto a refractory brick. The slag, which is an oxide crust that has formed on the surface of the molten metal, is removed, and the metal is poured into the mold. The mold is allowed to cool before breaking out the part. Casting does not produce net-shaped parts. The excess aluminum must be cut off at the gates. Heat treatment or hot isostatic pressing may be done to improve the material properties of the part. Typically, some machining is performed for any areas that require tight tolerances to improve surface finish and remove parting lines. Investment casting is a precise casting process used for intricate parts and high-temperature, high-cost materials like stainless steel and precious metals. Investment refers to the refractory material used for the mold or shell into which the metal will be poured. Investment uses either a wax, polystyrene, or other plastic pattern that can be burned out with little ash. Our investment table uses a cylindrical flask filled with investment, but other large-scale methods use a dipping process to build up the thickness of the mold shell. Wax patterns can be connected to form a tree of many parts to speed up production. The patterns can be made by hand, cast from a permanent mold, or made on a 3D printer. Our vacuum casting machine performs two functions. Investment slurry is a mixture of water and very fine silica powder. After mixing, there will be air bubbles present in the slurry. The left side of the table pulls a vacuum on the investment slurry to remove the air bubbles. The wax pattern is adhered to the cap of the flask, and the flask is filled with investment. Once the investment is dry, the cap is removed, and the flask is put into a box furnace to burn out the wax and fire the investment. The hot flask is then placed on the right side of the vacuum casting machine table, and the molten metal is poured in. The investment is porous so the vacuum will pull the metal into all regions of the mold and remove gas from the molten metal. Our investment casting table is the style you would typically see in small jewelry manufacturing.